Hi Professor, my name is Nitinsai Karuturi and this is my project for the Image Analysis and Computer Vision course. My project is about teaching a computer to automatically identify military vehicles like tanks and armored trucks from radar images. Instead of using a regular camera, we use here a special type of radar that can capture images even in the dark or through clouds. My goal here is to build a system that can look at these radar images and correctly say which vehicle is in the picture. The dataset I'm using is called MSTAR and it contains three types of vehicles, the BMP2, BTR-70 and the T-72. And coming to my problem statement, we can think of it this way. When you take a photo with your phone, you get a clear colorful image that's easy to understand. But radar images don't work like that. They look more like grainy black and white static, kind of like a TV with poor signal. This graininess is called speckle noise and it hides important details about the vehicle. And on top of that, the same vehicle can look completely different depending on the angle the radar is looking from. Just like how a car looks different from the front, above and side. And the third problem is that some vehicles look almost identical to each other in radar, even to a trained human eye. So the question I'm trying to answer here is, if we clean up the image first, remove the noise and highlight the vehicle, does that help the computer recognize it better compared to just feeding it the raw noisy image? And the dataset here I'm using for this project is MSTAR, which is publicly available. In this, each image is 128 by 128 pixel radar chip focused on one vehicle. An important detail is training and test images are captured at slightly different angles, which simulates a real-world scenario where the system sees the vehicles from angles it wasn't trained on. And coming to the review, I have observed through my research that approaches to this problem have evolved over 30 years. That is from simple template matching in the 90s to handcrafted features with SVMs in the 2000s to and deep learning CNNs from 2016 onwards, which hit a high 90% accuracy on this dataset. And also the latest trend adds attention mechanisms to handle visually similar vehicle classes as well. Coming to the design options, I considered three approaches: a classical HOG plus SVM pipeline, transferring learning with a pre-trained network like RESNet and a custom CNN from scratch. I choose this custom CNN because it gives the best accuracy, trains on a regular CPU without requiring any GPU, and is the right size for this small dataset. And coming to the justification on my approach, the table here confirms that classical ML caps out on accuracy. Transfer learning struggles because regular photos and radar images are very different. But the custom CNN wins on all these three criteria, that is accuracy, compute cost and the data fit, which are the three constraints that matter most for this project. And coming to my image processing strategy, this is the core of my project. Before any classification, the image goes through four steps. First one is speckle reduction using specialized radar filters. Second, CFIR segmentation, a smart thresholding technique that isolates the vehicle from background clutter. Third, morphological cleanup to remove any stray noise. And fourth is a fixed size crop centered on the vehicle. And here you can see the pipeline flow as well. So the whole project is essentially testing whether this pipeline makes a measurable difference over no pre-processing. And coming to my approach and scope flexibility, I have also planned for scope changes if more is needed. I can add an attention block to the CNN or extend to the full 10 class dataset. If scope needs to shrink, I drop the baseline experiments, but the core pipeline stays the same either way. And finally, to summarize, I am classifying three vehicle types from noisy radar images using a custom CNN with domain-specific pre-processing. I will evaluate with accuracy, per class precision, and recall and a confusion matrix. The key contribution is cleanly isolating whether that pre-processing step actually helps. So this is all about my project proposal, Professor. Please do let me know if there are any scope or design related approaches which are better than what I have choose in this project. Thank you.